chi-square test for independence. So upon successful completion of this particular session, you will be able to understand, you are able to determine when to use chi-square test for independence. You know that when you have a independent variable given and you have a dependent variable given, and both are given in the form of category and category, that means you are going to apply the test called test for independence chi-square. Clear? So you are able to find out the proportion exactly, that what was the proportion under each category. Clear? So what you are going to do, you are going to while exam, for example, if examiner want to give you the chi-square test for independence for the exam, it is going to give you a table called contingency table. So what you have to do, you have to make a subset of the contingency table that I'm going to show you in the next slide. So for that, you are able to conduct the chi-square test for the independence, and we will explain our hypothesis as well as we will calculate the interpolated risk and the relative risk for the both the proportions. So you can see here the chi-square test for independence, and this is the equation. In the previous test for goodness, what we did, the value was O minus E sum of square divided by expected. So what you have to do, you have to add one more figure. In this one, you have to add frequency. You can add F here, you can add F here, and you can add F here. That means here I have written INJ, so no need to write INJ. You can write the formula in such a form, like this also, like I have written. The chi-square test for independence equation is sum of frequency of observed minus frequency of expected square divided by FE. So what we did, just add this F stands for here frequency, and you are going to get the equation for the chi-square test for independence. That was the difference. That means what you are going to do, here you are going to write F, here you are going to write F, here you are going to write the F. So that is the difference between the goodness of fit and the test for independence equation. Here, so equation, once you understood, you are able to calculate also. So like this, you are going to find during examination. This will be called as contingency table. Now, it means, you can see contingency table is having a 9 subsets on the example which I have shown to you. That means we have a sample, these where I will make yellow. So this will be taken as a sample value A, B, C, D, E, F, H, G, H, and I. That means we have a 9 sample. Clear? So this will be called as, for example, your independent variable, and samples will be called as your, see, anyone you can take. You can take this one as a dependent variable, and the sample you can take as a independent variable. So for example, here I have given one example to you, that we are going to compare BMI with the blood pressure. BMI with the blood pressure. So BMI is sorry, here this is BP. BMI is classified into 3 different types. For example, your sample 1, sample 2, and sample 3. Your normal BMI, overweight, and obese. So blood pressure is your mild hypertension, moderate hypertension, and severe hypertension. For example, this is mild, this is moderate, and this is your severe hypertension. If you will take the classification of blood pressure as per your stage 1, stage 2, or stage 3 hypertension, like this. So you will have a category 1, 2, 3, and you will have a sample 1, 2, 3. So this table like this will be called as a contingency table. So what to do? You have to calculate the rows, total of rows, and total of columns. So what you do, this table you are going to get in the examination till here. Whatever the area pink color is there, this you are not going to find out. So this you have to do it yourself only. For example, if you are calculating for sample 1, you have to calculate A plus B plus C. If you are calculating for sample B, you have to calculate for D, E, F, and if you're calculating for sample C, you have to do the sum of G, H, and I. Clear? And total of row and total of column will be called as capital N, which is given here. This is your capital N. Clear? So degree of freedom for this particular test is R minus 1 and C minus 1, because here you have a two different variables. One is your independent variable, second is your dependent variable. But in test called goodness of it, you were having only dependent variable. So that case we did N minus 1 for the last test. But here, so 1 for row minus 1 we will do, and 1 column minus 1 we will do. So for this, by using this formula, we can calculate the degree of freedom for this particular test if you want to find out the probability level from the ChiSquare table. So hypothesis says what? As you know that hypothesis is classified into two different types, null hypothesis and alternative hypothesis. Null hypothesis says two categorical variables are independent of each other. Alternative hypothesis says that two categorical variables are related to each other. Clear? Now, this is the example how you are going to apply the test for independence. One example I have taken, but I just want to remind you the equation that chi-square for the independence you can write like in such a way: sine of chi-square, that sum of, you can make bracket, frequency of observed minus frequency of expected, square root of that divided by frequency of expected. Here, so once you got this frequency in the equation, you can assume it's a test for independence, and here you are going to find a contingency table. Like you can see here that this is the contingency table where I have mentioned the example. This is called a contingency table till here under the blue box. You are going to ignore the totals. Here, like this, you are going to get in the exam this table. That means now you can see what was the equation given and the numerical given. A random sample of 500 US adults. That means 500 US adult population you have taken, and you have distributed a questionnaire, and you are asking about their political affiliation and their opinion कि भाई आपके स्टेट में इलेक्शन होने वाले हैं. अब यूएस में तो इलेक्शन वैसे भी जनवरी फरवरी में होने वाले हैं, तो यहाँ वहाँ पे ये चल रहा होगा. ठीक है, तो 500 लोगों यूएस के लोगों से पूछा गया कि भाई आपका जो व्यू है कि भाई कौन जीतेगा, जो या फिर जो टैक्स रिफॉर्म होना चाहिए, जो टैक्स रिफॉर्म का जो बिल पास होना है उसके बारे में आप क्या बोलते हैं, आपकी राय क्या है. ठीक है, तो दो पार्टीज है वहां पे, एक है डेमोक्रेट, सेकंड है रिपब्लिकन. ठीक है, तो जो लोगों ने रिस्पॉन्स किया वो 3 डिफरेंट वेज में किया कि उन जो फेवर में थे, जो अपोज कर रहे थे, और जिनका कोई इनडिफरेंट ओपिनियन था कि भाई ना वो फेवर में है ना वो अपोज में है, तो वो उनके नंबर्स आ गए. ठीक है, अब इसको लिखा कैसे जाता है कि हाउ दे आर गोइंग टू राइट. You have to make a subset for the chi-square. That means this figure is going to represent, this box is going to represent the person who like the Democratic Party and they are in the favor of this tax reform. Clear? तो वो उनका जो नंबर है वो 138 है. ठीक है, अगर मैं डी ओ ले लेता हूँ, डी फॉर डेमोक्रेटिक एंड ओ फॉर अपोज, तो उसकी वैल्यू आ गई 64. ठीक है, अगर मैं आर ओ लेता हूँ, इफ आई टेक आर ओ, आर इज गोइंग टू रिप्रेजेंट रिपब्लिकन एंड ओ इज गोइंग टू रिप्रेजेंट द अपोज, तो आर ओ इज 84. ऐसा है. तो व्हाट यू आर गोइंग टू डू, you are going to make a like this subsets and you are going to find out the proportion. So इसको proportions बोला जाता है, and you are going to find out the percentage. Actually these are numbers and small n, तो small n से आप percentage count की जाते हो and you are going to find out then where is the maximum percentage, clear, from this 6 आंसर्स। ये आपके पास ये 6 आंसर्स आ गए, ये वाले, ठीक है। अब यहाँ पे नंबर तो ज्यादा है, कि हो सकता है नंबर 138 इधर ज्यादा आ रहे हैं, ठीक है, पर परसेंटेज हो सकता है कि इसकी कम हो। तो आप फाइंड आउट करते हो कि भाई मैक्सिमम प्रोपोर्शंस कहाँ पे है, ठीक है। सो बाय सीइंग द हाईएस्ट नंबर वी कैन नॉट डिसाइड दैट मैक्सिमम परसेंटेज इज अंडर हेयर और अंडर हेयर, ठीक है, क्योंकि हमारे को इसका टोटल देखना है और यहाँ नीचे का भी टोटल देखना है, रो का भी और कॉलम का भी, ठीक है। मैं इसका एग्जांपल बताता हूँ आपको क्या है। सो दिस टेबल विल बी कॉल्ड एज 2 into 3 कंटीजेंसी टेबल, कि भाई यहाँ पे 2 सैंपल हैं, रिपब्लिकन एंड डेमोक्रेट, और जो उनके आंसर थे उसकी 3 कैटेगरी हैं, कि फेवर में, इंडिफरेंट और अपोज। दैट्स व्हाई आई हैव रिटन 2 into 3 कंटीजेंसी टेबल। तो कंटीजेंसी टेबल ना ये 2 into 4 नहीं है, कि भाई टोटल को आप नहीं लेते हो और इस टोटल को भी आप नहीं लेते हो। तो टेबल इज ए 2 into 3। सो 2 into 2 टेबल हो सकते हैं हमारे पास, ठीक है, 2 into 3 हो सकते हैं, 2 into 4 हो सकते हैं, कोई भी हो। तो वी कैन अप्लाई द ChiSquare टेस्ट फॉर दैट पर्टिकुलर। सो ऐसे आपके पास एग्जाम में क्वेश्चंस आते हैं, ठीक है। सो व्हाट यू हैव टू डू, as you know that for the goodness of fit test the expected frequency for each category is obtained by, कि भाई expected frequency अगर आपको काउंट करनी है, ठीक है, तो वो तो आपने कैलकुलेट कर दी थी goodness of fit में, कि भाई आपने एवरेज ले लिया था तो आपके पास 14 आ गया था, तो आपने यही 14 यूज कर लिया एज ए एक्सपेक्टेड फ्रीक्वेंसी, ठीक है। बट फॉर द गुडनेस फॉर द टेस्ट फॉर इंडिपेंडेंस what will be the expected value for the frequency, clear? For that what you have to do, you have to calculate by using this formula which is written below, कि you are going to use this formula to calculate the expected frequency, क्योंकि once this is the formula, clear, and you have already, you are going to get this, but you have to calculate that FE. So if you want to calculate the FE frequency for the expected, what you are going to do, रो का टोटल क्या है, कॉलम का टोटल क्या है, एंड डिवाइडेड बाय n। अब n क्या लेना है, n लेना है आपने ये, कि भाई आपके पास कितने सैंपल्स है, कि हाउ मेनी सैंपल यू आर हैविंग, क्लियर। सो इफ यू वांट टू फाइंड आउट दैट हाउ मेनी सैंपल्स यू आर हैविंग, व्हाट यू हैव टू डू, यू हैव टू सी कि हाउ मेनी row and column are there in a contingency table. For example, I told you that this is a 2 into 3 table, so your sample size will be 6. Even you can see like this, that how many responses you have got, except this total you are going to ignore and this total you are going to ignore. So like this we have got the 6 responses, so n will be taken as 6. So total of column is 500. Here you can take, clear, and this total you can take. So by using a formula, row total and column total divided by n, you are going to get a expected frequency, clear. So what are the different method are there is the same which we have discussed in the last class, last topic, that goodness of it. You can add all those value in a equation and you can calculate the chi-square value, and chi-square value whatever you are going to calculate, that you are going to match with a table. You will have a chi-square distribution table like this, okay, and you can see that your degree of freedom for test for independence is r minus 1 and c minus 1. So if your r is, for example, 3 and c is 2, so 2 minus 1, 3 minus 1, you are going to get 2 and 1, total will be 3. So at the front of 3 degree of freedom, you can match how much is the value. If your value is more than, your calculated value is more than the tabulated value, you are able to reject the null hypothesis and your results are significant. Otherwise you can say, if your value is less than the tabulated value, you can say that null hypothesis do not rejected, or you are not able to reject the null hypothesis, and result was found non-significant at the alpha level. जो भी आपको अल्फा लेवल लेना है, 0.05 ले रहे हो या 0.01 ले रहे हो, तो उसके अकॉर्डिंग आप कहाँ पे काम कर रहे थे। at which conference interval level you are working. According to that, you can decide and you can write your results. So that's the difference between the test for independence and test for goodness of it. I will let you know that how we are going to apply the ChiSquare with the help of software called SPSS. These are the steps which you have to follow for the ChiSquare test. If you are going to apply with the software called SPSS, you have to click on Analyze, then click on Descriptive Statistics, and cross tab is the main option where you are going to find a test called ChiSquare. So this visual bind, why I have written in red color, because the data of BMI which you are going to take will be given in the form of number when you have taken the data from the hospital. So what you have to do, by using a visual binding command like we did in ANOVA, you have to convert your numerical variable into a categorical variable. So once you got the category of BMI or the category of blood pressure, because blood pressure data also you are going to get in numbers. It's systolic blood pressure or diastolic 180, 90 or 120 by 80, you are going to get in numbers. So what you are going to do, based upon the any official classification, you are going to make the different category. For example, stage 1 hypertension, stage 2 and stage 3. According to that, you are going to make a different groups. So by using a visual bind command, you can convert the numerical data into a categorical data, and if you have a both variable, independent as well as dependent in category, then only you are eligible for the test called ChiSquare. So this is used to convert the numerical data into categorical data. So once you have both the variable in category, you are going to apply the ChiSquare in SPSS. So one variable you have to keep under the row, one variable you have to keep under the column, and you have to choose the ChiSquare, and all these things you can see in the slides. So how to apply? This is the command. First click on Analyze, then go to Descriptive Statistics. Once you go to Descriptive Statistics, this window will appear, and here you are going to find a command cross tab for the ChiSquare test. So you have to click on the cross tab. So this is the window for the cross tab, you can see here, and these are all variables which I have made for my study. And from here, this is the BMI which is given in the form of number. That is, it's a numerical variable. So I'm not going to take this. I'm going to take BMI start, where BMI is given in the form of category, and you can see the sign here, the sign of category we have. Okay? And blood pressure already we have in the category. So one variable you can keep under the row, and one variable you can keep under the column. You can keep any column, any. You can keep the BMI under the row, or if you want to keep BMI under the column, you can keep. So here it's researcher's own choice that where he want to keep which variable. So it does not matter. So what you have to do, see, you can see already that I have moved the BMI under the row and blood pressure under the column. So once you will move the variable, you have to click on Statistics, and this is the very important step. Very IMP, I'll write very important step. Here you are going to choose that you are going to apply ChiSquare. You have to click check this ChiSquare under the option called Statistics. Okay, because this cross tab option is not only used for the ChiSquare, it is used for the multiple other statistical work. For example, correlation also. So you have to click the ChiSquare, and where most of the students are doing the mistake, they will just click the ChiSquare and they will run the test. They will click continue and OK. But before clicking OK, you have to go to cell, where a student are doing most of the time mistake, because you want the percentage. Then only you are going to find the highest proportions. Clear? You have to click on this row. This step you have to follow. I have seen several theses where the student have applied the ChiSquare test and data is given only in frequency and number, and percentage are missing, and percentage are not visible in their thesis. So it means you are not able to find the highest proportions. The main of this particular test is to find the proportion and to compare the proportion. And if you don't have percentage of certain subsets, you are not able to find the highest proportion. So what you have to do, you have to click on this percentage row icon. You have to check this row. Don't forget that. And you can click continue. You are going to get a results for the chi-square. So first table which you are going to get is the case processing summary. So this will be called as descriptive statistics somehow. It is going to tell you that test will be applied on BMI and blood pressure. So one will be your independent variable, second will be your dependent variable, like that. And it is going to give you the number of n, that how many sample was there, is there any case missing or not. कि अगर मिसिंग वैल्यू आती है तो यहाँ पे डिस्प्ले होगी, अदरवाइज नहीं. अगर आती है तो फिर आप ये वाला टोटल लोगे. अगर मिसिंग वैल्यू नहीं है तो आप ये वैलिड वाला डाटा ही ले लेते हो. ठीक है. तो ये टेबल से आपको बता रहा है कि भाई हाउ मेनी नंबर ऑफ केसेस यू आर हैविंग अंडर योर स्टडी. Second is the cross tabulation table, which is very important, and from here only you are going to find the exact proportion. And the next table, chi-square table, will suggest you that your results are significant or non-significant. And here you can see that one side we have a BMI, and one we have another variable is our blood pressure. Blood pressure is having two different categories. This normal and high under the blood pressure. And under the BMI, we have a three different category: normal, overweight, and obese. Clear? And you can find here that the value for normal BMI and normal blood pressure is this. This is your N, and this is your percentage, 58.8%. Now you can see, I will show you one example. Why percentage is mandatory and very important here. You can see somehow, yeah, you can see example of this, that for the n number 10 we got 58.8, and for number 54 we got percentage 56. Now you can assume that you can compare 10 with 54, how much difference we have here. Clear? And percentage for 10 is 58, and percentage for 54 is 56, and this is n, and this is your percentage. Now you can see why percentage is important here. By just showing the numbers you are not able to decide. If 10 is less than 54, but the percentage of 10 is higher than 54, this one you can assume. So from this table, what you are going to code, you are going to find out that where is the maximum percentage. Here you can see the value of 54 and value of 10 is there, but their percentage is 58, 56, but we number are 30, and percentage is highest is the 78.9. This 78.9 you are going to quote in your results. That means the maximum proportion was seen under the high blood pressure and people having obese category. And you can write the person who are obese, it will be assumed that their blood pressure will be high most of the time. Okay? Like this you can quote. So from this table, what you have to do, you have to see these, you have to ignore the totals, you have to see all these 6 values. These 6 values you have to see, and you have to see that out of these 6 values, for example, this is first percentage, this is second, this is third, this is fourth, this is fifth, and this is sixth. Out of this 6%, which one is the maximum? The maximum percentage will be quoted in under the results. And last table will be the results of your chi-square test. And what you have to do, you have to see the p-value. This one, it should be less than 0.05, because confidence interval of the test we are taking 95% confidence interval. The cutoff point will be this. So this value should be less than 0.05, and we have got less than 0.05, and we can assume that result was found significant, and we are able to reject the null hypothesis. That means कि भाई अगर किसी का BMI नॉर्मल है ओवरवेट है और ओबीज है तो उनका ब्लड प्रेशर भी डिफरेंट होगा, उनका ब्लड प्रेशर सेम नहीं होगा. If the person are having a different group of BMI, their blood pressure is also different. Okay. So how the results will be written? Like see here, the software is also going to calculate the degree of freedom, like we did in the statistical method manually, and we got the value of chi-square also. And at degree of freedom 2, if you want to compare what is the value at 0.05, you can compare here. Degree of freedom 2 value is 5.991. Here, so you can compare 5.991 with the value of chi-square 14.82. So 14.82 is more than 5.991. We can assume that our results are on the higher side, and we can say our results are significant, and we are able to reject the null hypothesis. So how the results will be written? Results will be written in a MLA style. So this is the writing style for the chi-square. What you have to do? You have to write the sign of chi-square first. Then under the bracket you have to write to degree of freedom. That degree of freedom is equal to 2. Then you have to write the chi-square value. This value chi-square which I have taken, and p-value which you have got. Clear? This p-value you are going to write. And one paragraph you can write where you should mention the highest proportions. कि जो आपका highest proportion आया था, this one which we have got in the table, the highest proportion you can write, and you can compare with these two groups. That means you are writing about obese, so you should write in such a way that you are comparing with overweight and you are comparing with the normal. So how will be written? You can write, it was pretty obvious that the proportion, because you are comparing the proportions or percentage, clear, of obese group, proportion of obese group who had high blood pressure, because you can see here the obese. Now where you got the maximum percentage, this is the maximum percentage, and it is under the obese group, under the high blood pressure, under the high blood pressure. So what you are writing, it was pretty obvious that the proportion of obese group who had high blood pressure was higher, so and so, compared to both normal group and overweight group. That means what you did, you are going to compare obese with overweight and normal. So this is the way how the results will be written for the chi-square. And what you are going to do, you are going to see the maximum percentage. So if you have any doubt that how the chi-square will be applied with the help of SPSS and under the test for independence, you can ask the queries. After that, I will close the session.